Math Man.
Alright, welcome back students to Mathmen's Algebra Academy. This is going to be Chapter 1, Lesson 7, Simple and Compound Interest. Let's go ahead and get started. So first we're going to talk about simple interest. There is a formula, I equals PRT. That stands for I, the total amount of interest earned. P is the principal, the amount you started with. R, the rate, which is a percent written as a decimal. For example, 5% would be written as 0.05. Then the T is the time in years. Let's look at example number 1. To be able to take her dream vacation, LaShonda decides to save for 4 years. She opens a savings account with $400. The account pays simple interest at an annual rate of 2%. She doesn't make any more deposits, and they want us to find out how much total interest does LaShonda earn, and also how much total amount would she earn, including the interest. So, first we take our formula, I equals PRT, and we insert the info from the problem. So first we have the principal, which she started with, which is $400, so we put that in for P. The rate is the percent, it was 2%. So, to turn that into a decimal, you take 2 and divide it by 100, so you get 0.02. The time is 4 years, so we put that in for T. All you have to do then is calculate all those things. Multiply them together, and you get $32. So, the amount of interest that LaShonda earned was $32. Next, we want to find out the total amount of money in the account. So, she started with $400 and earned $32 of interest, so we add those things together and we get $432 total. Not too bad. Now let's look at a second example. John invested in a savings bond for 4 years and was paid simple interest at an annual rate of 3%. The total interest earned was $360. How much money did he invest? Well, in this scenario, we have our formula, I equals PRT, except something else is missing that we remember from last time. They gave us the amount of interest that was earned, which is I, and they gave us the rate, and they gave us the time. What they didn't give us was the principal. So, we have to use the properties that we learned from literal equations in the last lesson to solve for P, principal. So, we have to divide by RT on both sides, because we already know R and T, and that will leave us with P equals I divided by RT, so we can find the principal by putting the interest that was earned divided by the rate times the time. Now, we put the data in and we solve. So, P equals I over T, interest was $360 that was earned, the rate is 0.03 because it was 3%, and the amount of years was 4. Once we calculate all of that, we end up with $3,000, which was the principal. That's the amount of money that he started with in the savings bond. Now we need to look at compound interest. We have a different formula for this one, and it looks a little complicated, but once we get used to it, it's not going to be so bad. This time we have an A, which is the final amount after all the interest has been added. Then we have the principal, the amount we start with, the rate, which is the percent, write it as the decimal again, T is the time in years, and N, this is a new one, the number of times the interest is compounded or added. Let's take a look at an example. In example 3, Steve deposited $4,000 into an account with a 5.1% interest, compounded monthly. Assuming no withdrawals are made, how much will he have in the account after 8 years? So now we have a new formula to look at. Let's write it out. A equals P times 1 plus R over N raised to the NT power. Now again, I know this looks crazy, but first we're going to put all the information in that we need. But we need to identify that data from the question. So he deposited $4,000 into the account. So that's the principal. The rate is 5.1%, so if we divide 5.1 by 100, we get 0.051. The amount of years is 8, and then the number of times it is compounded Well, it says it's compounded monthly. Well, there's 12 months in a year, so that means it's compounded 12 times. Now we've got to put the pieces into the formula. So we got to input the data from the question, and it'll look something like this. Now if you type this into your fast EOC calculator, or if you have a smart calculator you can do this in, that's awesome. If not, do this individually using order of operations, and you'll get your answer of $6,010.03. This is the amount of money that he'll have in the account after 8 years. Alright, look at example number 4. This is the last one, so let's get it right. Greg borrowed $8,000 at a rate of 11.5% compounded quarterly. Assuming he makes no more payments, how much will he owe after 3 years? Alright, so let's look at our formula again. A equals P times 1 plus R over N raised to the NT power. So we're going to identify the data from the question so we can do this right. The principal, again, is $8,000. That's the amount he borrowed and started with. The rate is 11.5%, so we write that as 0.115. The time is 3 years. And the number of times it is compounded is quarterly. So quarterly sounds like quarters. 4 quarters in a dollar, 4 quarters in a year. So 4 times it's compounded. Now we put that data into the question using the formula, as you see right here. And the answer to this is $11,241.08. Alright students, so now you've learned a little bit about simple and compound interest, and this is a skill that you can use long after you're out of the algebra classroom. So, if this video has been helpful to you, drop a like and subscribe to the channel so I can keep helping you get through this algebra stuff, and then you can pass that EOC. So until next time, let the math keep mathin'.